What's up everyone, welcome to this ProACTive tutoring video. In this lesson, we're going to wrap up our functions discussion by talking about domain and range. So let's get started. So what is domain and range? So domain is defined as the set of all defined x values for a function, and range is defined as a set of all defined y values for a function. So let's look at a function to help us understand this. Let's say f of x is equal to x. Right? What is our domain for this function? And when we talk about domain, we need to ask ourselves, what are all the possible x values that I can input into this function so that I get a defined output? If you think about it, you get that the answer is all real x values, right? Any x value you put in, you'll get an output, which is just itself. Right? So our domain is referred to as all real numbers, or negative infinity to positive infinity. And these parentheses, they stand for non-inclusive. All right, because we can't really use infinity, because infinity is such an abstract concept. It's not really even like a number, so we can't say that x can be infinity. But our domain goes from negative infinity to positive infinity, because any value in that set can be inputted into this function. What about our range? So what are all the possible f of x values or y values for this function? And again, if you think about this, you'll realize that any real number can be our y value. Right, so our range for this function is also negative infinity to positive infinity. And if you think about it this way, if we graph this function real quick, we just sketch a quick graph, f of x equal to x, it's going to look something like this. Right, and this line will extend. This line will go on forever and ever, which illustrates that we can have any x value on the x-axis and any y value on the y-axis, that we will have some point on this graph defined there. So domain, you look at the x values, we can input any value into this and we'll get a real output. And we look at our range, what are all the possible real outputs? Any real number would suffice. So our domain and range are both from negative infinity to positive infinity for this function. Let's look at a couple more examples. So say we had the function f of x is equal to x squared. Right, what is the domain for this function? So in other words, what are all the possible x values so that this function is defined? If you think about it for a minute, you might conclude that any x value will work, right? We can input any x value and we'll get an output, which is that input squared. Right? So our domain is from negative infinity to positive infinity. Now what about our range? So what are all the possible y values for this function? And so far we've been getting negative infinity to positive infinity for our domain and ranges. However, that is not the case for this range, because if you think about this, f of x is equal to x squared, right? So what can x squared not be? X squared cannot be negative, right? Our range, our y values cannot be negative because y is equal to x squared, so y will always be greater than or equal to 0. So our range is actually from 0 to infinity. Right, and the 0 is surrounded with a bracket, and the infinity is with a parentheses always, and this right here means inclusive, right? Because our range can be 0. If x is 0, then y is 0. So our range can be 0, but that's the smallest it can be. It cannot be any negative number, because when you have a real number squared, you will always get a number greater than or equal to 0. So this is our range. Now let's take a look at y is equal to square root of x plus 1. All right, what is the domain and range for this? So what is the domain for this function? Well, the domain for this function are all the possible x values such that we have a real output. And we have a square root here, so we need to think about this carefully. What are all the possible x values so that we have a real output? This only occurs when the things under the radical, right, has to be greater than or equal to 0. Because you can't have a negative under the radical and expect a real output, right? If you want a real output, you're gonna have to have a positive value under the radical. So this quantity under the radical has to be greater than or equal to 0. So we do x plus 1, which is greater than or equal to 0. Get that x is greater than or equal to negative 1. So our domain is actually from negative 1 to infinity. All right, because anything less than negative 1, we will have a negative value under the radical, and we cannot take the square root of a negative value and get a real output. And negative 1 will work because we can take the square root of 0. If we plug in negative 1, we'll have the square root of 0, and we can take the square root of 0. So that's why negative 1 is inclusive. Now let's look at our range. So what can y be? Let's think about this. We will have a positive value under the square root, right? We'll always have a positive value under the square root. So when you take the square root of a positive number, right, the square root of a positive number, what do you end up with? You end up with a positive value, right? And even for 0, if x is negative 1, right, you'll have the square root of 0, and you'll get that y is equal to 0. So note the range is from 0 inclusive to infinity, right? Because you cannot take the square root of a negative number, so the square root of a positive number is always positive. But we need to remember that we also include 0 because 0 is a possible output if x is negative 1. So this is the domain and range for this function. All right, let's take a look at one last example. So you guys try this one now. All right, so we're asked to find the domain of f of g of x. So first, we should find what f of g of x is. Right, so f of g of x. So we know that f of x is equal to the square root of x plus 1. And we know that f of g of x is going to be equal to the square root of g of x plus 1. Right, and g of x, and this is equal to, what's g of x? We know that g of x is x minus 3 cubed, so this is the square root of x minus 3 cubed plus 1. So we need to find the domain of this function. So what is the domain of f of g of x? Let's write it here. The square root of x minus 3 cubed plus 1. So what are all the possible x values for this function? Well, all the possible x values, we have a radical, right? We have a square root, so we need to make sure that everything under the square root is greater than or equal to 0. Right? So we have this x minus 3 cubed, and we need to make sure that this is greater than or equal to 0, right? Because we cannot have a negative value under the radical. So we do x minus 3 cubed is greater than or equal to 0. See the cube root of both sides, we'll get that x minus 3 is greater than or equal to 0. When we add 3 to both sides, that x is greater than or equal to 3. And this makes sense to us because we know that if we plug in 3 for x, we'll get the square root of 0 plus 1. Right? So anything less than 3, and we will have a negative value under the radical, which we cannot have. So we know that x has to be greater than 3, greater than or equal to 3. So our domain, since we have greater than or equal to, is going to include 3. And we can have a very large x value, and we will still have a real defined output. So our domain is from 3 inclusive to infinity, and our final answer is choice C.